Greetings, everybody. Welcome to this stream on the Easter Sunday weekend. This show is dedicated to the Christian God, to Jesus Christ, whom we profess to have been raised from the dead long ago. And really, what the exploration of evidence and reasons for the Christian faith, as far as I'm concerned, is establishing evidentially that Jesus rose from the dead. Not that it'd be a great idea or that it would help us to just, have a body of beliefs just to make us better human beings, but rather whether it's a historical fact. It says in the Bible that the kingdom of heaven is like treasure hidden in a field. God has chosen not to be as evident to our everyday senses as the air we breathe. And like a hidden treasure, part of this channel is to help provide those who are seekers to see that there's more evidence for the Christian faith than, let's say, the unsupported claims of abiogenesis theory or some of the major claims of evolutionary theory. I would think that there are many atheists. Even though, granted, there are theistic evolutionists, and I may or may not deal with that in this show. But atheism cannot survive on the idea that life is miraculously created, because if life emerged through either a few miraculous events, say less than 10,000 years ago, or several miraculous events over long ages, it still indicates there was a miracle. And if there is a miracle, there's a miracle maker. One other thing that we know is becoming more and more evident is that if life is intelligently designed, it is also cursed, because there's lots of pain in the world. The Christian faith claims that life is intelligently designed, miraculously created, but also cursed and in need of a savior. One reason we explore intelligent design is to establish that there is a creator. Now, I want to respect those who are old earth creationists, who are ID-friendly theistic evolutionists, and then of course, young earth creationists. I'm a young earth creationist. I used to be a theistic evolutionist, then a old earth creationist, and a young earth creationist. If we can even get, I think, reasonable evidence that the human life in particular is young, that would affirm the genealogy of Jesus Christ in Luke chapter 3 and Matthew chapter 1. Beyond that, we can explore arguments that the fossil record is young, and then that leads to maybe the Earth being young, the solar system, and maybe even the whole cosmos being young. And so the arguments we'll explore tonight, and then kind of like the bad arguments for some of these ideas, are arguments that are used to support intelligent design and or young Earth creationism. The distinction is that if you're a young Earth creationist, you automatically accept that there is a creator, therefore you accept that there is an intelligent designer. The converse is not necessarily true, because there are people that are not young Earth creationists but accept intelligent design. Most prominently is Michael Behe. So this channel does cater especially to students of science, like PaleoLogos here, who goes also by Peter, and graduate students and professional researchers. This is not a channel that is intended to be subscribed. And if my policy is the success of a channel is that it has been faithful to God's word, and that it has told the truth and has taught excellent science. There's some pretty big channels out there, like Guts at Gibbons. She's a friend, but I have to say, if that's the size of the channel is the measure of success, then she would be more successful than a channel like this one, which I believe we actually tell the truth. We're actually much more accurate with the science, and we certainly are honoring to God. So with that, introduction. Peter, if you'd like to say anything you think the audience should know about you, please feel free.
Yeah, thank you so much for having me on. It's a pleasure to get to speak with you. We've kind of been around a little bit, but it's great to be able to talk with you in person tonight. I just wanted to say that I really appreciated your channel and a lot of kind of the in-depth things that you've gone through, particularly in terms of radiometric dating lately. I've been enjoying that. A lot of it is probably beyond my comprehension, but I think that you do a good job of presenting kind of all the evidence kind of in terms of a more holistic kind of view of things that support our view, things that don't support our view, with what we know and kind of what we don't know. And I think that really appeals to a lot of people in terms of honesty. So yeah, I am a student under Dr. Todd Wood, for those who don't know. I'm in high school and I like talking about hominins, and yeah, I have a small channel where I do that.
Well, I look forward to helping you along in your journey. One reason this may sound strange, but I feel a little more comfortable with old Earth creationists who are in school, because I feel that their viewpoint on the knowledge base we have now is actually pretty defensible. Like, it doesn't exactly agree with my interpretation of scripture, but it is worlds ahead of naturalistic abiogenesis and Darwinian evolution for sure. Now, as I've been trying to argue on my channel and some of the shows you've seen, that the mainstream, there's enough dissent in the mainstream that they're starting to become more and more of an opening for young Earth creationists. Meaning, if they actually will look at the literature, just like, for example, last week I was covering heavy electron quasi-particles, and it's like I think I'm the first creationist that even suggested this to provide a means for nuclear transmutation. And I've argued also mixed energy reactions, and then the high energy reactions that involve photonuclear processes through things like
I hadn't heard of most of the explanations that you were giving
right.
from any young Earth creationists.
Right.
So,
and I felt they needed to be covered. And I really do think we've got a shot at those. And I think it's also very interesting science. I'm finding the same thing starting to develop in all sorts of fields of cosmology. And then even in biology, there are angles to attack evolutionary theory that I'll be presenting on at the Creation Research Society conference at Liberty University, July 21st through 23rd. I have applied to make 2 presentations, which is my limit. I have co-authors Joe DeWeese, John Sanford, and Henry Whitler. So greetings to Sandy Pigeon. I worshiped with him today at Cornerstone Chapel. It was packed out. People were coming from as far away. We are in near the DC area. People were coming from Connecticut, nearby Maryland, Pennsylvania, North Carolina. And I had the privilege of worshiping twice today at Cornerstone Chapel, Gary Hamrick's church, where we're, that's kind of what they call the epicenter, or the center of gravity for a lot of trying to push back the woke agenda. And oh yeah, someone was there from Chicago.
Wow.
So people are driving long distances to go to this church. Sandy and I worshiped today. He and his lovely wife and daughter. And then I had pizza, and we were just kicking back, talking about all sorts of things. I got to hold this pump action shotgun for the first time in my life. And it's pretty cool. So, and we just got to talk about all sorts of things. And so I was rushing home, trying to, it's about an hour drive to get home from Sandy's house. Sandy, many of you know that Sandy was has been an occasional guest on this channel. And so shout out to Sandy here. And thank you very much, sir, for your pizza. God bless you for that. So I was about to say,
Please do
some
at
of the,
least like put it in the microwave and warm it up, though.
yes. So what I wanted to say is, and this will relate to some of the things that we're going to talk a little bit about nested hierarchies, and I've had some bad creationist arguments for that. I actually didn't have a chance to put together my list. And happy Easter, Dr. Duff.
Yes, hello.
I'll say happy Easter here since he showed up. So why don't you open with some of what you think are bad? You can either identify it as a bad intelligent design argument or a bad young Earth or both.
All right. Well, I guess I'll jump right in here with the argument modern humans predate other types of humans and the Australopithecines. And this is an argument which is fairly common. It's heard from a lot of young Earth creationists, the idea that modern humans basically predate any other type of form of humans, such as like a Homo erectus or, any of like the Australopithecines even. And there's kind of two main creationist sources, young Earth creationist sources for this. One of those would be this book here, Marvin Lubnow, Bones of Contention. And the other would be Contested Bones here. So
that
both
hurts. No. This is you are. This is a good example. You are free to criticize me and my colleagues and even my mentor. So please.
Well, this doesn't have anything to do, but they make the argument that modern humans do predate these other. And I think they right. This all kind of goes down to radiometric dating and kind of what faith we place on stratigraphy and all of that. So this is a kind of conscious one to start right off the bat with.
No. Can I just, if I could say this?
Certainly.
My principle is when the other side, our opponents, agree with us, that's what I would consider the gold standard.
Mm-hmm.
And there are times you'll be surprised when they do.
Yeah.
And then so if people are wondering, how do I decide what's good and bad? I'll just give a simple example. If the other side says you need multiple universes or space aliens to solve the problem of abiogenesis, then you're standing on pretty good ground. Because they're basically admitting the improbability. And there are a few things that you can find, and that's what I would always say, let that be your starting base. Then you get to a little bit more and more controversial after that. So when at least when I'm ranking these in terms of good and bad arguments, the bad arguments are like, well, is it even rejected within the creationist community?
Mm-hmm.
Both by
evolution. The reason why I bring up this is because
so, go ahead.
I don't think this issue is necessarily even fundamental to young Earth creationism, though it's often portrayed as such. So maybe I'll kind of begin by Marvin Lubnow. Marvin Lubnow is kind of the famous, iconic young Earth creationist author on the topic. So he argues that he kind of does recognize these various kind of distinct groups of humans, such as, Homo sapiens, a species to which we belong, and we have some unique, features of our skeleton. And he, in his book here, makes the case that Homo sapiens basically predates everything else, or at least is as old as the supposed precursors, right? So he's trying to undermine the idea of human evolution, saying, that these creatures, the Australopithecines, which would believe to be ancestral to humans, are not in fact, and that Homo sapiens in their present form actually coexisted with these creatures. So he gives kind of a list in the back of his book, and basically he has a whole list of these various skeletal remains, and he gives the radiometric dating and tries to argue for their various dates. So here I have his chart pulled up where he talks about Homo sapiens, and he begins with the very oldest thing being the Laetoli footprint trails in Tanzania. And that was his opinion of the very, very oldest, evidence that Homo sapiens was pre-existing or coexisting with the Australopithecines. And this is something that I hear brought up a lot, and I think this is a particularly kind of poor argument to make, because it's very hard to assign a footprint to a particular species. Creation Myth says, to Peter's point, Neanderthals are descended from Adam and Eve is a genuinely terrible argument. Same for Erectus and Heidelbergensis. Well, in my perspective, that is basically the only kind of coherent creationist argument that you could make, considering that they do appear to be, fully human. But anyway, back to the Laetoli footprints. As I was saying, a lot of younger creationists would like to, say these are human footprints. And I think this is kind of jumping a little bit to a conclusion, because there have been some studies that have pointed out that these, in some respects, are indistinguishable from those of modern humans. And there's been other studies where they've seemed to see differences in gait, or perhaps in some width of the morphology that would indicate maybe it's not a Homo sapiens. So I don't think this is at any means settled, but I think it's particularly poor to argue that this is indeed a Homo sapiens, because, for example, we know a little bit about the feet of Homo erectus. And from what we know, their feet were very similar to our own. So much so that we couldn't tell the difference between a Homo erectus foot and our own foot just from a footprint. Right. And so at that point, that to me, at least, seems to be kind of poor evidence to try to argue that this is a Homo sapiens. And based only on a footprint.
No, I appreciate that. And you'll have to forgive me. I actually know nothing about any of the names you just threw out. There are a couple of creationists that don't want anything to touch with human evolution. And maybe if I could show kind of my sentiments on this.
Here's the guy I'm talking about. This is Homo erectus.
Let's see if I can bring this up. Apologies here. I don't have my usual setup because I'm migrating a little bit away from, now that it's getting warmer. I can be on the main floor here, not in my little cubby hole, but then I don't have all my computers with me. So this is a graph. I show how creationists, they like to focus where Erica there is very knowledgeable, and also the evolutionary biologist and anthropologist. Erica and I are very good friends. We've agreed not to debate each other. And, to me, maintaining my friendship with her is more important than trying to score public debate points. But what I've tried to say is this little thing ends up generating so much of the focus of creationists. When Dr. Sanford came to McLean just the night before his NIH talk, everyone was wanting to focus on this. And he and I have had some discussions on this. I said, why don't we focus down here? We could absolutely just obliterate the common descent argument in the sense that if you assume common descent, you'd need miracles. And you'd have pages and pages, and you don't get hardly any opposition.
I think I agree with you, but I think there is a reason why we tend to focus on that specifically. And that is because for a lot of like created kinds, I think it's hard to, say based on the Bible, actual like distinctive boundaries for the created kinds. Whereas for humans, right, that is actually one of the places where we have that laid out specifically by the Bible.
Yeah. Well, okay. So this is where it's a little difficult. It's like sometimes the thing we're eager to prove, maybe God hasn't provided us yet the evidence. I
Mm-hmm.
would say if you prove the earth is young, it's a done deal. You're going to have a very easy time. Um, I mean, definitely there wouldn't be chimp human ancestry. There's just not enough time if you only have 10,000 years. And even a million years would be really pushing it.
Right.
So that I said, okay, trying to argue over bones and DNA, it's like maybe take on the harder problem of just showing that the fossil record is young, or slightly harder problem that the earth is young. Then you're home free. There's You've just eliminated practically a large swath of the primate ancestor, primate cousins.
I mean, I
And
think
you,
it's important to focus on all of those things. I think we could
yeah.
agree. Yeah.
Um, but I'm just saying where I found the easiest argument is where you see it right here.
Yeah. No, I definitely agree with you.
I,
That is
and,
definitely
and,
the
and what ends
single
up
major
happening
problem.
is if you score only a draw in these debates and you just don't overwhelm the opponents, the other side is essentially won. And so
Mhm.
uh, unless one is, if one has convinced on a scientific basis that the earth is young or the fossil record is young, then um, everything else becomes a much easier proof. So,
Yeah.
um, so maybe you could educate me a little bit. I just sorry I had to give my little rant there,
No, that was good to
tirade.
kind of hear that.
Huh?
That was good to hear kind of your perspective on that.
Yeah, yeah. Um, because when I hear Erica and Dr. Dan and all these anthropologists, these paleoanthropologists, I said, they are making they're making credible arguments. I'm not necessarily saying I
Hmm.
agree, but I'm like, I can't, unless I have some other data point, I'm going to struggle. And that's why I just don't like to fight that battle. I,
Hmm. And
and
that's why I think, particularly for younger creationists, trying to argue Homo sapiens is the first human, or predates these Australopithecines based on the fossil record that we have, is just a losing argument, that it's
okay,
just going to become a worse and worse and harder to cling to for those who are trying to argue
okay. So
this.
can you clarify? All right, like I
Yeah.
said, you're the expert on this. Australopithecines is not considered a human.
Yeah. Okay. So maybe I should go back a little bit. Okay.
Okay,
So Australopithecines are like Lucy species. So these creatures, sorry, this is an example of one right here. It's from a cave site in South Africa. It's very, very famous skull, sometimes called Mrs. Ples.
it's
Um,
big. Is
it
that the
is.
scale?
It is. Yeah, to scale. And
I'd almost think that's a gorilla. I mean, it looks so big.
well, the thing is that it has like an even bigger brain to body ratio than a gorilla. So these things had an enlarged brain, like compared to gorillas, and don't have a lot of, uh, yeah, they're quite different from a gorilla though in terms of a lot of morphology. Um,
Okay,
but these things appear in many respects somewhat human-like, particularly in respects to their locomotion.
so if
And
we go by the
um,
mainstream dating, you're saying that um, this predates humans. If we go by mainstream dating, and to argue otherwise
correct.
is not a good argument.
And even stratigraphically, when we're looking at the relative position of sites to one another, um, it is this thing is predating humans. And
Meaning
my
lower,
correct,
lower.
it's lower and down in the strata.
Okay.
Yeah. And what I specifically said there was that it's predating Homo sapiens, right? Because Homo sapiens we can define, as this very distinct morphology. Um, Now, I do think ultimately that, the human fossil record does extend back further than we have evidence for right now, based on the Bible, because I believe that, the human fossil record must go back to the flood, right? And then beyond that, if we could find fossils. But right now, the human fossil record peters out in the post-flood era. And then right now, before these human fossils that we find these fossils of these Australopithecines. And so, the secular community would believe these to be, or not even necessarily, but kind of the conventional community would believe these to be ancestral to humans.
Fabulous. Well, that was very educational. And so when you say predate, this is the mainstream date.
Correct.
Okay.
Yes. So these people like Marvin Lubnow, their attempt was to basically take the radiometric dating and basically show that even when they used conventional dating methods, they were still wrong. The conventional community. That was kind of Lubnau's whole kind of practice. Basically, give them as much ground as they want and still prove them wrong was kind of his goal.
Okay. Now,
yeah.
Just for the sake of transparency, I did contribute to the book Contested Bones. I did not touch any of the fossil record or paleontology or any of that. My contribution
and,
was...
I'm actually great friends with Christopher Rupi. He's a really great guy. I've gotten to talk to him before.
Great. My contribution was for the Alu elements. And I've covered that a lot.
You told me that I had to go back through there and kind of read that section again. And
it was a month of work, and my report was chopped down to a page and a half. I'm like, Dr. Sanford, this is really good stuff. So you'll save it for another publication. So I'm just saying that just so the viewers know who I am and my involvement in the project. It does not signify that I endorse everything in the book, and that's also difficult because Dr. Sanford's my friend and mentor, and Chris Roop's my friend. But we're just, the idea is, let's get a feel for what the other side has had to say, and has the other side, have Erica and others agreed with your view about Australopithecines, according to the mainstream, predating Homo sapiens? Is that
yes fair? I mean, especially Homo sapiens. Yeah.
Okay.
I mean, we can't even argue that Homo sapiens was coexisting with the Australopithecines. Like, okay, they don't even like exist in the same layers. Like, okay, other human types do, like Homo erectus perhaps, or Homo habilis might go down into kind of the Australopithecine layers, but Homo sapiens doesn't go down that far.
Okay, so now just to back up a little bit, I'm going to throw in what I think are bad ID and creationist arguments. But that being said, all right, people know that I think the creationists have definitely won the abiogenesis argument. It's getting ridiculous how bad abiogenesis is becoming. When they start appealing, first they started appealing to extraterrestrials, and now multiple universes. And we probably got some who probably believe that multiple universes and extraterrestrials, although that hasn't reached peer review. But, what has reached peer review is multiple universes. So I definitely think there is good evidence for a creator. I think eukaryotic evolution is totally collapsed. I think it's a disaster to be claiming that this can happen naturalistically. So that being said, I will be willing to criticize my own side. I think some people here would be curious to find out, well, okay, so you basically given the mainstream view and described it according to them accurately, that the Australopithecines, according to the mainstream date, predates Homo sapiens. Mm-hmm. I have to ask, on what basis, and it's the same question that'll be thrown at me, do you still remain a young earth creationist, and that you believe that they actually coexisted? I can give you my answer, obviously, but you can I think the viewers would be curious to hear.
Could you rephrase that? I didn't quite catch that.
Why are you still a young Earth creationist? Because you have data points that seem to conflict with your personal view, and I have to face the same. I'll answer that same question. I want to give you a chance to, because people would be
yeah. Okay. So I think you're saying, okay, so the Australopithecines from the fossil evidence we have predate humans and specifically Homo sapiens, and why am I still a young Earth creationist if that is actually the case? Well, overall, I think that the case that the Australopithecines evolved into humans is somewhat weak. I know there have been, members of the conventional community who have actually, published against that view, saying that it wasn't even possible for the Australopithecines to evolve into humans. And I think I would probably kind of fall into that view as well, that the morphological disparity between the groups shows that there was never a transition. Now, the order of the fossil record then still is an issue for me, undoubtedly, as I think it is generally. And the problem being that humans appear so late in the fossil record. And that's not just humans, right? That's a problem for young Earth creationists and in some other respects as well, where we have a lot of major mammal groups appearing very, very late in the fossil record. And, ultimately, I think that these groups did not evolve from one another because I don't think that evolution can modify an organism to that extent. And so ultimately, I think I don't know that young Earth creationists have a perfect explanation of the fossil record right now for why exactly it is the case that so many creatures would appear so late. But I also think that it isn't possible for the groups to originate or share a common ancestor. And so in that respect, then I think that young Earth creationism can explain the independent origins of these groups. And I think the explanation of why they would be fossilized in different layers is much less of a burden than to try to explain how exactly they could have originated from a common ancestor.
And what you said is very close to my viewpoint. So since I posed the question to you, I'll pose it to myself. Why am I still a young Earth creationist? I think there might be plausible mechanisms that could be discovered, and people will say that's not an answer. And I'll say, well, okay, so if you believe in abiogenesis and if you believe in naturalistic eukaryotic evolution, you're in worse shape than where I am, because I can give you mountains of problems that I don't think in principle you could even overcome.
Mm-hmm.
Whereas the idea that there could have been some mechanism that would make like the mammals appear at higher levels, that doesn't seem anywhere near the order of astronomical improbability of eukaryotic evolution. And not even eukaryotic evolution, there are transitions like, say, between the angiosperms and gymnosperms to angiosperms, or animal multicellularity.
Right.
We could name any number of things, and I'm like, okay, if we're going to be fair here, which takes a greater leap of faith, in my opinion? And I'm like, I'm going to have a hard time. I'm at the point in my life, it's going to take me more faith, despite the evidence in theory, to believe evolution can proceed naturalistically, and even more so for abiogenesis.
I think that's especially the case in the hominin fossil record, where we have basically, once you get to rock layers that are dated around like 3.7 million years old, suddenly the fossil record just becomes extremely poor and extremely fragmentary, whether you're talking about groups that preceded the Australopithecines in the fossil record. The human fossil record peters out. There are some things that seem to extend very far back, a specific jawbone that it's very hard to assign to, but things in this particular group become so fragmentary that I'm very, wary of saying that these things were not around, given how fragmentary things begin as we get back further.
And one thing that does disturb me is when we get kind of out of place fossils, we'll just say, okay, that's some sort of intrusion or whatever. And just like, you don't absolutely know that. And so there, you could have, there could have been things that were found and they're like, no, that's a mistake, or that just happened to get intruded there. It really wasn't part of the original. It's like, how much reworking has there and how much confirmation bias is involved? So,
well, that's a good point that you bring up there, because that's kind of tied to one of the points I wanted to make as well, which is about one specific skeleton in particular, which a lot of young Earth creationists talk about, called OH1. And it comes from this famous site called Olduvai Gorge in Tanzania. And back in the 1930s, there was a man, Dr. Reck, who was excavating this site, and he found a pretty complete skeleton. And basically what happened was the skeleton turned out to be in these rock layers where they were finding some very early Homo erectus bones and also some bones of the Australopithecines. So this caused a lot of disagreement among the conventional community, right? Because here they have this series of transitions, and why is Homo sapiens, this descendant species, showing up with these creatures that are its ancestors long before it's ever supposed to have originated? And ultimately, that turned out to be an intrusive burial. It turned out that much later on, people had dug down into these sediments and deposited this body down in there and covered it all up. And it was misinterpreted as having been fossilized right in that layer. And that, is another example of, Homo sapiens not being down in those layers. The only time that we find creatures that are Homo sapiens down in those layers is when people have intentionally buried and deposited, corpses down in those layers.
Well, that wasn't exactly the example I was hoping you'd describe, but thank you. That's a good data point. I will point out there has been a little bit of fraud. About 20 years ago, there was some paleontologist that was reporting bad carbon-14 dates. I don't know if you know his name. It starts with a Z, I think. Von something. Anyway, let me just say I just don't get the sense that this is an insurmountable problem, the stratigraphy. And the other reason is I really don't buy that the fossil record could have been laid down over millions of years. There are mechanical problems with that. And the whole thing with chemical dating still seems to suggest that the dating methods, radiometric, are off. So we can either try to figure out how the chemical dates are broken or how the radiometric dates are broken. And obviously, when I cover stuff like heavy electron quasiparticles, that's where I'm going. So, of course, people could be agnostic on the issue. They could be Christians, but agnostic on the issue of the fossil record. There are a lot of those. And I personally have no issue with that. I don't think it's a salvation issue. And, if they want to say, well, I could go either way, I'm not going to get in their face and say, you heretic, because you're not a young Earth creationist. That's just not my, I don't sense that that's something that this, there is a right and wrong answer, but that's not something that I ever saw in the early church as being something to be raised to the level of heresy and worthy of expelling people out of the church. So,
I am inclined to agree.
Oh, I'm glad to hear that. So now, since Creation Myths is here, and that's Dr. Dan, I'm going to throw out one that he helped me be even more forceful about. Irreducible complexity.
Mm.
I'm not saying that the idea is bad. It actually comes from Charles Darwin, and the failure is the rhetorical device. Charles Darwin said if it could be found that some organ could not have arisen by slight gradual changes, my theory would utterly fall apart. Now, that was a paraphrase as close as I could. But that's where Behe said, oh, irreducible complexity. And this causes problems from a rhetorical standpoint. If we had just said, we need to just find one example, and then we find some candidate examples and they're not able to really do a good job falsifying it, then we could argue provisionally, not absolutely, provisionally, it looks like Darwin has failed. And recently, my colleague Joe DeWeese, who I published with, and he's co-author of even some future things with me, God willing, professor at Vanderbilt Medical College, Vanderbilt School of Medicine, and also Fried Hardeman, biochemist, professor, worked on topoisomerase. I don't know if you saw the topoisomerase video. I hope.
I did not, unfortunately.
Oh, okay. One thing I noticed is what are very good arguments for that the evolutionists and the evolutionary community don't want to even touch. Topoisomerase is one of them. And I think the membranes and eukaryotic evolution, it's just like, I wish the creationists would prosecute this more because you're not getting any opposition. I mean, they'll say, well, maybe it's this or that, but they're certainly not going to be able to come forward with, anything that's really strongly experimental, and certainly not anything the fossil record. I've not seen them come up with compelling statistical arguments. They'll claim natural selection, and I'll say, no, that doesn't work because it would actually work against the formation because dead things don't evolve. You tinker with something that's life critical, or if it's missing, it's going to be dead to start with. It's a non-starter. So I don't know where I lost my train. Oh, so irreducible complexity. So what will happen, and I saw this, and I just cringed when I heard my creationist colleagues say, oh, irreducible complexity is a problem for evolution. So Otangelo did that, and he went up against Dapper Dino, and sorry, Otangelo's here. And I told, Otangelo is writing me, so what do you think, Sal? I said, don't use that argument, because I'll tell you what they're going to do. They're going to find some system you have no familiarity with. They're going to claim it's irreducibly complex. Whether it is or isn't, they're going to catch you in something you don't know. They're going to claim it's irreducibly complex, and then evolve from precursors. Unless you're 100% familiar with the system, why go there? You're setting yourself up to fail when you say irreducible complexity, and these guys can just throw stuff at you you have no familiarity with. You can't even refute whether it is irreducible complex or not. Whereas all Darwin said is you just need to find one example. So why come up with a definition where they could come up, the opposition can come up with a bazillion examples. You have no way of finding out whether it is irreducibly complex or not, much less whether it evolved. What you should do is pick systems like topoisomerase, helicase, transmembrane proteins, zinc fingers, like a zinc finger transcription 3A. When you get specific systems, then you're able to prosecute your case. And then I've noticed that, that's when they fold. So I'm saying the sentiment is correct. The way it's prosecuted is not. By trying to make this overarching thing that it's a problem for Darwinian evolution. Darwin himself said you just find something that can't be evolved in gradual incremental steps. And that's all you have to do. Just find physical examples. And so, rather than saying it's always going to be bad, because that ends up, I don't know, that's my tirade. So I just say the sentiment is correct, the implementation is wrong. And in the last presentation at the Discovery Institute, when they're showing topoisomerase, they didn't even use the word irreducible complexity. They just went right back to Darwin's Origin of Species and said, look, topoisomerase fits this. Do you have any problem with that? No one has responded. No one has even tried. And I doubt anyone will be able to. Certainly not on the internet, because Joe DeWeese has studied this enzyme for 17 years. He's published in the prestigious scientific journal. And if anyone heard his talk for an hour and 15 minutes, you'd know the guy knows his stuff. And so that's what I'd say. So I gave you the bad version of the argument, and I'd say this is the way to correct it. You can still prosecute the sentiment of irreducible complexity, but this is the way you do it. You come in hand with a few molecular examples, and I think you'll be good to go. And we've tested some of these out. We're going to have more. So and I'm sorry, Otangelo is here. I'm going to get, out of courtesy, Otangelo, great to see you. Angelo, oh no, that's Dr. Joel. Hang on. If you had some comments while I try to bring this up for.
Oh, I was wondering kind of what your view is on the idea of whether or not irreducible complexity should be somehow made more systematic and more rigorously defined, but it sounds like not.
No, and I have to give credit to Dr. Dan, and he grilled Dr. Michael B.
Yeah, I watched that debate earlier this week, actually, which is kind of what started me thinking about, the importance.
What I wanted to say is, you see, this is where you don't want to be. And Dr. Dan did an excellent job. And Dr. Dan, if you're listening, you've heard me compliment you on this, and it was kind of hard for me to watch because this is seeing my side maybe not have its best day. And I said, look, Michael Behe was there for 45 minutes just trying to define what irreducible complexity was and what it wasn't. And I said, this is getting nowhere. What if you just throw out some examples that follow Darwin's recipe for what would break his theory? Put these examples on the table, then you have a real conversation, not these abstractions. So to your question, my thoughts are, no, it's not a matter of defining it more. It's a matter of just finding examples that fit Darwin's recipe. And we don't even have to, it's good that Darwin wrote it, but logic would say, the idea is, he says, natural origin of species by means of natural selection. And then really what he's saying is Origin of Species, chapter 6, organs of extreme perfection and complication, right, which is really can natural selection build these? So all you have to do is find something. You could say it'd be very unnatural for any sort of differential reproductive success to construct this. And so any of these things that are instantly lethal, it's like if you change them, it's probably not evolvable. And they'll say, well, that's not, the way it is now isn't the way it was then. And of course I'll say, okay, on what basis can you say that? Do you have any proof? Or is that just a belief? Because then you're forcing them to indicate they're making assertions without any evidence. Yeah. They'll say, well, the ancestor didn't look like anything like this. I'm like, well, how do you know that? And how can you prove it? And two things, they obviously don't know how they could possibly know that. And if that's the case, they're certainly not going to prove it. And, they might appeal to something future. And it's like, okay, fair enough. But that rises to the level of faith, a creed. It doesn't, rise to empirical theory, empirically confirmed theory. So
this might be a little off topic, but
please.
since this is kind of chill, what's kind of your view about calling evolution a religion?
All right. The way to avoid yourself getting into trouble is you quote an evolutionist. You quote Michael Ruse, and he says Darwinism is a religion. All right. So you may be disagreed with, or they may disagree with Ruse, but it is kind of comical to hear one of their own defenders call it a religion. And
Do you think it's important whether it is a religion or not? I mean, kind of from
you know what? I would just say it's important to show whether I call it, no, I wouldn't say whether it's a religion or not. But I think
because I feel like
sometimes,
that's kind of conceding the point that religion isn't a valid way of looking at the world, when we do think that religion is a very important and very valid way of looking at the world, and that not everything can be explained by natural processes.
well, I would just say this, that um, I try to be, I'm a minimalist when it comes to kind of more rhetorical arguments.
Yeah. I
So
mean,
I
it's
wouldn't,
really semantics.
right. But if I could just say, okay, you don't have theory that actually demonstrates that this should happen, it's an assumption. If it's an assumption, that means it's not proven. It's a faith statement. And they'll say, well, evolution is the most proven thing. And it's just like, well, if it is, then how come you can't prove this to me? You can't even prove it to yourself based on biochemistry, what we know about cell biology, etc. I don't have to say it's a religion.
Yeah.
I can say it's an unproven thing that you accept.
I don't think calling it a religion really changes any of the arguments at all. I mean, like,
It,
whether it is
it
true or
just
not,
ends
it's
up.
just not necessarily helpful.
It's not necessarily. It's. I don't think it's helpful because it starts to be, kind of inflammatory. Uh, you know, my my view is don't hurt the opponent any more than you need to. Don't just just try to be as polite as possible, and and say, okay, is it fair to say you don't have proof of this? You're making an assumption. And then they might give you, well, look at the chimp human ancestry, and just like, or look at where evolution works. I'm just like, well, you haven't proven that you could extrapolate chimp human ancestry to eukaryotic evolution or the origin of major protein families. So let's grant that chimps and humans share common ancestry. Can you solve this problem or that problem? Can you solve topoisomerase? Is it transportable? And so if you're making these unwarranted extrapolations, then I'm just trying to show that your assertion is really just a faith assertion. It is, I'm just trying to be properly skeptical here. If you're going to make a claim that it's proven, you have to follow kind of the recipe of what constitutes a proof. And I'm afraid that's not been done. In fact, I've given reasons why I think it's absurd. So, so back to your question, I try not to use those words. It's just too loaded.
Yeah.
It's just,
I would agree.
it tends to say, because then we also have our theistic evolutionist guys, and it's like, this just it starts getting into rabbit trails. And I've been in this debate long enough, and it's like, just, they love rabbit trails. Just try to avoid this. That's just my feeling. So,
Yeah.
okay, now it's your turn if you wanted to give another bad ID or creationist argument. By the way, thank you very much for that one about the Australopithecines. Is that one, by the way, is that claim also made in contested bones?
Yeah, it is. Should I mention kind of how they bring that up a minute, or
Sure, go
should we
ahead.
move on? Okay, so in contested bones, they use a little bit of a different argument than Marvin Lubnow did. So they bring up some different fossils to make their case. So they bring up some footprints that were found in Greece that were dated to, I think it was around 13 million years old. And so they argue that these are the footprints of something that was walking upright, and they argue it was a human. Unfortunately, it actually appears to have turned out that those weren't actually footprints at all. They were just natural depressions in the ground. Which I think it's kind of interesting, though, that when people are trying to make this argument, it often gravitates towards footprints, which is not a specific way of just defining what creature is making them, especially when all these different types of humans have feet that look so similar. And a lot of this stuff, the further back you go, just the more fragmentary it gets, based off of single toe bones and things like that. And at that point, I'm kind of like, well, that's just pretty skimpy evidence to go off of to claim Homo sapiens was back then based on a single toe bone.
Yeah. And for that reason, again, this is why I've been hammering at trying to show that the fossil record is young, because all of this becomes moot then. Because if it's young, then it says, okay, we may not have an explanation for this stratigraphy, but we know that they pretty much coexisted.
Mm-hmm.
And that's all you need. And you have the most important part of the proof you need. And it's because of these, like you said, kind of the skimpy lines of evidence. So, I mean, I'm beating a dead horse here. So, I mean, I will say that I recall a conversation when I was very excited about discoveries of problems with eukaryotic evolution. And I called Dr. Sanford. I said, we could dump exploration of human evolution. And I realized quickly, I said, oh, he just published a book on this. I better not say that. And I shut up real quickly. And I said, okay, Dr. Sanford, I'm just going to continue looking at this. He's, changed Tan's paper on this. And that's the end of the conversation. I basically just dodged the bullet and said, there's, I want to give my friend, colleague, and mentor, the freedom to express his ideas. We've not always agreed. I'm pleased to announce he has he's co-authoring another project with me, actually two.
Okay.
So, and I think that's healthy, that even people that are co-authors on the same paper at times will have different viewpoints on something else. I mean, both he and I think the fossil record is young. It's just a matter of how we wish to prosecute that case. I happen to have kind of a little bit of physics background where I can kind of explore areas that, Chris and John haven't. So, I had a little bit of an out. So anyway, thank you for that about the footprints in Greece. I mean, this is really, I'm just like, gee, it's really hard to, I don't know. When I look at footprint evidence, it's like, wow, that's it's certainly not a physical
the
fossil.
issue is that there's also evidence that there were these other creatures around that time in Europe, these small, we don't know exactly what they are, either monkeys or apes, that may have been somewhat bipedal. So at that point, it's like, okay, well, these footprints are very well undefined. Even if they are footprints, which is granting quite a lot, you can't prove that they're human. So
interesting.
Yeah.
All right. Do I have another one? No transitional forms. Oh my goodness.
What is a transitional form?
Well, see, my point is, why go there? I've told people don't use it, and for a very simple reason. You go to school, you start to do phylogenetic trees, and you can clearly see that you can put a lot of things in sequence. So if you have one form, you could see all the things that are close to it in similarity, especially molecular phylogenies, ones that are very far. So from just kind of a cursory look at this, it's like, well, certainly the chimp would be kind of transitional from, like, say, from a yeast to a human. The chimp looks transitional. in a sense, because the chimp looks closer to the human in similarity. Or was the human transitional to the chimp? Or, since creation myth is here, I know he's going to ding me on this. Really, it was an ancestor to both of them that we can't, we might build a consensus. And I'm like, okay, we're getting to semantics there. But the thing is you can't deny that there's a progression of from very dissimilar to similar.
Yeah, the
And
question is what that represents, right? I mean, like,
and that's the topic of my creation society presentation, and
oh,
I'll
wonderful.
briefly cover that. Do you want to hear it? It's actually not
Yeah, definitely. I want to hear it.
okay. If you're a young earth creationist, definitely then the patterns of similarity and diversity were created. It's created diversity. What is the purpose of this? And what is the purpose that we have kind of a sequence of organisms from very dissimilar to very similar to us? The answer is this. If you ever seen like a pencil in water, it looks bent, or you've seen pictures of it. Okay,
Refraction.
evolution is like that. Evolution is like geocentrism. You can look at the data and conclude something that's totally wrong. Like you could think that the the solar system is geocentric when it's actually heliocentric. You can think that a pencil is bent when it's actually straight. Uh, you need a lens to correct it. So if the Earth is young, what you really need to explain is why you have this pattern.
Hmm.
There, the simple explanation, and I'll elaborate on it, is that it's optimized to help the scientific process. We can understand biology because of the diversity of forms. I mean, like for example, how did we deduce the human genetic code? Marshall Nierenberg was studying bacteria. He had some assumption that it was similar enough to us that we could reconstruct the genetic code. And it turns out that was very providential because the architecture of the human genome is very complicated. It's very nice we have these what we call model organisms that we could study. They're similar enough to us that we could use them to study. They reproduce like rabbits, really more like bacteria, and it makes the process of discovery better. When we really want to find organisms that are really good candidates, it'd be things like chimpanzees. I don't think people appreciate this, um, how valuable that is. I found out the hard way. I was taking a neuroscience class at the FAS graduate school at the NIH, and I was assigned to do a term paper, term presentation on a glutamate receptor or something. And, I was assigned a postdoctoral student to work with. And I was asking the postdoctoral fellow, I mean, and I said, how did they, what were the cells here? He said, oh, they're embryonic stem cells. My heart sunk. It was from an aborted fetus. I think the cell line's called HEK. They actually didn't have to do that.
Yeah.
With a human. They could have taken a chimpanzee. Even a dog might have been an adequate model organism. So for those who are Christians, they understand the idea of an animal being sacrificed to take our place. And ironically, this is exactly what's happening in the medical profession. Because we are similar enough and we have this progression from very different to similar, it can actually help us understand ourselves. And there's actually some interesting things. We can actually learn about human biology by studying yeast. Even plants are not on anywhere near kind of on the pathway to humans. Even the squid, the squid giant axon, we can study neurobiology. So that's one part. The second part is, why are the molecular sequences, if you're familiar with the amino acid sequences across, oh, that's great. We can't actually, a lot of our fold prediction algorithms, they succeed because of the patterns of similarity and diversity. If those patterns were random, it's a testable prediction, and I'm pretty sure it's correct. If the patterns were not cleverly designed, we could not do fold prediction of the proteins. If you think about it, the way we store the 3D fold, like in protein data bank, we'll say XYZ coordinate. And then here's the next, this amino acid has XYZ coordinate this. And then this amino acid has XYZ coordinate like this, relative coordinates predict the 3D shape. And that's a pretty interesting data file. Well, what you can do is you could actually just take that protein, the homologs across a variety of species, you run it through an algorithm, you basically generate that 3D file. That's like voodoo. And if this were a random pattern, you would not be able to do that. What's also interesting, if you start to pull certain organisms, your full prediction will fail. So this means there's preconception in each of these things. That's what I'm basically going to present on. And we have confirmation of this in the AlphaFold program. It's definitely in the direct coupling analysis, and then some of the work that Joe DeWeeser and I and others co-authors on what we call the K-modes algorithm. And I'm like, yeah, this is definitely not random. This is something natural selection would not favor. There's no reason it would. Certainly not random mutation is going to make this. So a consequence of those patterns of similarity and diversity is you will get a nested hierarchy. And that's the explanation for the nested hierarchy, not common descent. So I figured I'd just throw that out there. And I'm like, again, like with the heavy electron quasi-particles, I'm like the only creationist so far that is throwing that out publicly. And so I'm glad to do it so I could get a little bit of priority credit, but it's really God who should get the glory for that genius.
Yeah,
So I hope you like that
interesting
answer.
idea. Yeah, I'll be looking forward to kind of your more full presentation paper.
Thank you. I'm going to do a rehearsal on this channel as I do before, because I'm be up in front of a large crowd, and I haven't been accepted definitely yet, but I was told, they said, "Oh, Sal, if we would hope you present." So I hope that my the abstract I submitted will get accepted, the two of them actually, and that I'll get a chance to present. And even if I don't, I'll present it here.
Okay.
So one way or another, it's going to be on this channel, either as a
Great.
rehearsal or just because I want to do it.
I'm scrambling a little right now to get a paper done, hopefully to present. My deadline's May 1, so I am.
Yeah, my deadline was April 15th. So
yeah.
I made that deadline, but so I don't know how long it'll be before I hear back from them. So okay, so your arguments so far that are bad for young Earth creationism, Australia, Homo sapiens didn't predate Australopithecines according to mainstream, and that the footprints in Greece may not even be footprints, which was cited in contested bones. Okay, and then I said irreducible complexity has the right sentiment, but it's the implementation that's bad. And secondly, saying that the no transitional forms is not a good argument. Don't even go there. Argue something more positive. So I'll hand it back to you now.
Okay, so this is more what I think is a little bit of a misconception. Okay, so from a young Earth creationist perspective, right, we think that there are these created kinds that are unrelated, and the kinds stem back to these original created ancestral populations that were created on the 5th and 6th days of creation, respectively. Often I hear creationists talk about micro and macro evolution. And often, I think you get the perspective. Creationists, young Earth creationists believe in microevolution, not macroevolution. And I think that is a bit of a misconception, because since these terms have kind of been defined, microevolution has been defined as, evolution, change in allele frequency that's happened in a species. And then macroevolution has been defined as evolution that has produced a new species or, beyond that even. So I think sometimes young earth creationists happen to equate the species with the kind and then say microevolution is the only thing that's occurring. What are your thoughts?
Okay, this is Dr. Dan had a Ask Me Anything with me and Emery Moyna, who's a graduate student, and then Guzman, that
Okay.
may be his first or last name, and then me. And I said, Dr. Dan, tell me about what you think about speciation. And he said, well, there was a graduate class, and by the end of the class, no one agreed on what the definition of species is. And
Yeah.
I said, that's all the more reason creationists should not even go there. You're not, the first thing is you're going to come up with your definition of speciation or what a species is. And no one's going to agree with you. And you're just going to get, again, into these things that I hate, which is definitions.
Hmm.
It's easier if you, rather than, uh, just as a general thing, yeah. All right. And I was like, Dr. Dan, you really helped make my point. It's like creationists don't go there. And when Nathaniel Jeanson came up with his own definition of species, I just rolled my eyes and like, Nathaniel, you're not helping me, because I know not every creationist agrees with your definition of species. I certainly don't. I don't, because I don't care. Um, and I said, just avoid the whole thing altogether, because what you're really trying to do is you're trying to show that things were created by a miracle, especially kind of humans or major forms. And and I said the easiest way to do that, or really the easiest way is actually the hard way. Prove the fossil record is young. Prove the Earth is young. Everything will flow nicely from that, because it starts to be apparent that certainly plants and animals couldn't, in the short span of say even a million years, come from a common ancestor. And
Right. And since I think species is more of a nebulous term, what we should be talking about is more evolution that happens somehow leading to the creation of what we think are two distinct created kinds. And that is really what we should be talking about, not some distinction between micro and macro evolution.
and and I'm going to get pushback from my, I don't know if you're sensing it. There's kind of two camps within creationism. You have the baraminologists that are obsessed with kinds, and then you have the anti-evolutionists. They're like, I don't
Mhm.
care about the kinds. I just want to show evolution's wrong. I obviously am grouped in the latter, and so is Dr. Sanford. We're not baraminologists. We've talked to creationists. We've tried to discourage them from becoming baraminologists. And Dr. Wood is a baraminologist, and Kurt Wise, and I think Emery is a baraminology guy. And and so where I was headed with that is, um, I think it's easier to, rather than saying what's a created kind, what is a created discontinuity? This okay, this is my second presentation, if I can get away, or my first at the Creation Research Society. The one was on uh, the folding predictions,
Yeah.
and I think that's really the most cutting edge one. But the first one is discontinuities in major protein families. And by way of extension, you could see organs and organelles. So if you could demonstrate discontinuities in the organs rather than the whole thing, that might give you a clue of what the created kinds are. I mean,
Right.
definitely plants and animals have different cell types. So you could at least say there exists one created kind in the plants that's different from a created kind in the animals. You may not be able to identify it, but you could say there's a discontinuity here. And then I would just kind of just say, okay, what discontinuities can we definitely see between chimps and humans? And so what I've been seeing, unfortunately, is these large scale genomic comparisons. And like that's, I don't know what to do with that. Whereas if you go to individual proteins, or individual organisms. Like I heard like the ear is constructed differently in the chimpanzee versus the human. I think that's a pretty good discontinuity.
So you think specializing rather than holistically more on specific morphological features that you don't think
Yes.
can actually change,
Yes.
or at least can't change into the supposed
Right.
descendant
So I'll tell you
condition.
why. Look at this. I mean, and again, you could correct me if I'm wrong because you're the primatologist here. In fact,
Not
I think
quite.
on the internet, you're the number one primatologist
What?
for young Earth creationism on the internet.
Hmm.
Um, yeah, I know it's kind of scary, isn't it? Given how little both you and I know, we ended up becoming the experts when we're really not. Um, but like, okay, if you're just comparing bones, it's like, well, yeah, they look kind of similar. But if you look at individual organs, there are some pretty distinct. Like the thing in the ear, you can't just redo an ear. Um, the way it's like the eardrum is there's something in the way it's constructed. Granted, that's soft tissue, and we may not have like the fossil intermediate, but it's like kind of hard to imagine what it would be like. So you could make a very good case just on individual portions, and if you want to extrapolate that to say this defines a created kind,
I think
I'm
that's
not.
an interesting point because even within baraminology, there are kind of different groups because there's the people who are trying to use like whole data sets, to um, actually find discontinuity. And then there is also the people who are trying to actually just look at groups and basically based on a couple characteristics, just like these ones are different enough from those to be just they couldn't have shared a common ancestor. Because like I was reading the other day, it was through an article about amphibian kinds, I think it was, and that was basically their approach. They're like, these are different enough from those, not the same created kind. And I don't know. There might be some issues with that, but I think you have a good point there about looking for those individual features.
Yeah, and again, I think this all proceeds from the premise of a young creation. It becomes very hard if we have an old Earth model to make that argument. So again, that's why this whole thing with radiometric dating is such a big deal to try to solve it. And then other things with the young Earth model that are, still very challenging. But the point is with kind of these isolated organs, it's like, okay, that really does seem like a leap that would be longer than would take. And um, I mean, I think it's reasonable that we don't have to do the whole data set. And actually, I'll point out that I think sometimes these whole data set comparisons may not actually highlight very important differences because one, our sequencing technology isn't that good, meaning we can only get little segments of the genomes when we do this, when we do all the chemical prep and then putting it in the sequencer, we get it in like anywhere from 100 nucleotide to 300 nucleotide fragments, and then you assemble it. And if you're hoping that you're assembling the sequence, the synteny or whatever it's called, of the genome. And I'm just like, Lord help us. If you get the order wrong, that could be kind of important in the way it affects the morphology. So, so I kind of like what you said. You had the two groups that are whole data set, and then the other group that is just like isolated. I would lean toward the isolated characteristics because then you can really see how different they are, especially if you can find significant orphan genes.
Yeah, I mean that immediately then becomes harder to talk about the fossil record, of course, since so much of this would be based on soft tissue, often
Right.
or DNA. But yeah,
I mean, I don't mean to be harsh, but I mean, I'm very concerned about just, I appreciate they want to explore this and think about it and argue it. But from my vantage point, even just arguing the young Earth creation case, we have still so far to go even to get to that point. Because I'm dealing with all the physics, and you see how hard I've been struggling the last 6 weeks trying to deal with just the issues of radiometric dating alone, and I'm not even done. So, um, So I mean, I respect that the fact that they're interested in this, and that's, um, uh, you know, so I mean, those that's just kind of my, you know, I think there could be a point that God is saying, well, will it really matter as far as whether Jesus is real, whether Easter Sunday really happened, you know? Whereas I think the young Earth creation argument, whether we're able to identify kinds or not, like say of dinosaurs, if we win the young Earth argument on empirical grounds, then we've won the Christian faith on evidential grounds. You know, at least that's kind of how I feel. And and you know, maybe it's interesting a question of whether the dinosaurs this or that kind. Um, I think in the scheme of things, it's not that big, but it may matter to one person, and you know, I want to respect that. You know, there are things in history that I study that have no bearing on the Christian faith, like the Battle of Midway. I'm just fascinated by some of the details of this, like what happened. You know, why did Yamamoto decide to turn his battle fleet after he lost 4 carriers? Not that the answer to that has any bearing on whether Jesus rose from the dead. Okay, that's just a personal interest, and I'm happy to, you know, be around other people that have it. And so I'm not trying to be too critical of what they're doing, but I just, you know, I do have to say, okay, um, it'd be helpful to say, you know, is this just a burning interest of yours, or does it have immediate relevance to the question of the resurrection, which is what we're talking about tomorrow? You know, so now you know what my biases are.
Yeah, okay.
Uh, Quick answer to Dr. Dan: no, I've never read Shattered Sword.
Hmm,
I never heard of that.
neither. Oh, on the Battle Midway.
Oh, was that about the Battle of Midway? Shattered Sword?
He said, best book on Midway, fascinating read.
Oh,
Yes.
wow. By John Parshall, I think. That sounds right. Parshall. Thank you. Wow. You're a very erudite man, Dr. Dan. Well, very well read. So, I don't know who was next. I had two bad arguments, and you had two or three?
I too, so you can go ahead now.
No, I think it's your turn to come up with
Okay.
a bad argument
All right.
for young Earth creationism and ID.
And I guess I'll jump right into chimpanzee human genetic comparisons. Now I'm not very knowledgeable on the subject of genetics, and I'll be the first one to announce that. But even to me, I understand that there are very, very big problems with the work of those who have tried to disprove, in particular, the human chimpanzee genetic similarity. Um, and there have been some recent kind of stuff about that, such as the Dismantled documentary, also the book called Apes' Ancestors, which Jeffrey Tompkins did co-author. And this, I've heard a number of younger creationists bring this up kind of when talking with me. And generally, I well, completely actually. I do think this isn't, first of all, I don't feel like it's that important of an issue. I mean, yeah. I mean, based on morphology alone, I mean, there's so many similarities between humans and chimpanzees. But
Agreed.
um, yeah, I mean, Jeffrey Tompkins was the one who kind of started this whole kind of discussion about whether or not human DNA was 98% similar to chimpanzee DNA. And his very early kind of works on the subject were flawed by some bugs in his program. And that was pointed out by some people who, in particular, let's see, it was Glenn Williamson who kind of wrote a paper about that, the issues. And over the years, he's had a lot of different estimates of genetic similarity, ranging all the way from like 70% to 88%. depending on which way he was doing things and everything. And then one thing, I was kind of looking into the controversy kind of about this, and from what I understand, the way in which, Dr. Tompkins did things was very problematic. So much so that even some other young Earth creationists, such as Dr. J. Weil, who originally had been supportive of kind of that whole idea from Tompkins, said in a later article that it is best to be skeptical of Tompkins' works on the subject. And so generally there were a number of issues. One was with exactly how he was comparing the nucleotides and whether or not large nucleotide sequences should have more prevalence than small ones. And there were the issues with exactly how you would compare an individual to itself and find it like only 80% similar to itself, I believe. And so generally, yeah, I think that's a bad creationist argument that young Earth creationists should not be using, because it's based on a lot of flawed methodology. There were a ton of problems in basically every kind of stage of the development of kind of that idea. And generally, I'm perfectly fine with the 98% similarity to humans, and I really don't think that's as big of an issue as perhaps Tompkins perceives that.
And I'm in agreement that, for the reasons I stated, that chimpanzees serving as a very good model organism for humans is providential. For a long time, I was like, God, why did you make them? Because you're making the job of creationists harder because they look so similar to us. And now, having dealt with, kind of the heartbreak of seeing embryonic stem cell research done on humans that could have been done on other primate species, I'm like, I began to thank God for them. And I thought I'd never thank God for rats and mice, but medical research wouldn't progress without them.
Yeah.
And thank God that they are similar. And we do have this progression. They are transitionals in a conceptual sense. I'm not saying physical sense, but in a conceptual sense, they are very good transitionals.
Well, that's why I like to use the term, rather than transitional, mosaic.
A mosaic. Okay.
Yeah, because I think that kind of better, because I know transitional does kind of give the sound, right, that
Evolution.
right. And I think maybe for young Earth creationists, a better word is mosaic, having kind
Is
of
that
features
a
of both,
term
but
people are
not being
using
ancestral
more?
to.
Mosaic?
I know there was some like articles by Kurt Wise had used that term in the past to kind of talk about
Yeah.
things like that. So I don't know, maybe
Well, Dr. Dan makes the point for us. If YECs are dead set on the absence of common ancestry because the Homo sapiens were specially created, what does the percent genome identity matter? And just like, well, yeah, that's exactly what Peter and I kind of feel. All right. And I
and I
don't get
think
it. It's like, is it going to be more compelling that it's like 90% versus, 92%?
I
I
think
mean,
I
what
yeah,
figure would make you think that we're specially created? I mean,
yeah.
unless you say, okay, if it's 99%, then we're not. Or if it's 99.5, then we're not. But if it's anything less than that, then we are. I'm just like, I don't know about that.
Yeah. Dr. Duff brought up an interesting thing here about kind of comparisons. And yeah, that's another thing that I was thinking about as well. So the way that Tompkins did his comparisons is unlike how everybody else was doing their comparisons of genomic similarity between creatures. So if his way was even correct, what does it even mean? Because he hasn't compared
Yeah.
humans to orangutans or to any other creature, or wolves to dogs or anything like that. So there's no comparative metric to even gauge whether that percentage is important or not.
And this is painful because Dr. Tompkins is very hospitable to me. He's a friend. My work with Dr. Sanford, it began a little bit. I got assigned to work with Dr. Tompkins for a month we were trying to do a chimp assembly from the old Sanger sequences because he didn't like the assemblies. He has done good work on calling out kind of the questionable practices of trying to lay out the human genome by using a human model. There are still, I think, some problems with that. I think he's done good work there.
Hmm.
But the percent thing, it's like, if we believe it's specially created, even with like a 2% difference, if the Earth is young, there's no way that that's going to happen.
I
That
mean,
it
yeah,
could
my first point is, first of all, why does it really matter to you, right? And second of all, yeah, I mean, then we have to have comparisons and we have to be doing things in a way that is consistent. And yeah, the way that if you're saying chimpanzees are 80% similar to us, you have no comparison anywhere else in the animal kingdom that you're making. So it's just kind of an irrelevant comparison.
Yeah. So it pains me if Dr. Tompkins is listening. It's like, I'm sorry, Jeff. I just don't see that. I mean, I think it's good to get a report on this. And, my default is I'll just go with the mainstream, which is 95%. That's enough. That's enough to say in a young Earth model, there's no common ancestry. Again, everything proceeds from showing that the fossil record's young. You show that it's young, 5% will show you that we're a created kind.
Mm-hmm.
There's no need to go to try to show it that's going to be 70% or 88%. Even 98% would probably do the trick. Maybe even 99%. Um,
I,
so, uh, th- okay. So while you please go keep sharing, and I'll think about the next bad argument.
There was just one other thing that I wanted to bring up, and it was that this man that kind of did this original critique of Tompkins um, was a computer scientist who basically was looking at the methods he was using, and he actually wrote a whole paper and tried to submit it to the Answers Research Journal, um, talking kind of about Tompkins and kind of the issue. And unfortunately, Dr. Tompkins happened to be the only reviewer there and basically refused to give input on that paper. And yeah, I think that is somewhat concerning. I think in young Earth creationism, because this is such a small community, I think that peer review can certainly be an issue, I think, because we just don't have enough scientists from
Yeah.
some of these fields to be able to provide as good of peer review as would be favorable.
Yeah, exactly. And so, obviously, I'll disagree with people on the internet. We've been privileged to have people like Dr. Dan, Erica, and even though Dapper Dinosaur isn't, as far as I know, a professional at this, he's really smart. And we have Dr. Duff and others. I think
Mhm.
it's very helpful to have a dialogue first before we even, we have a publication idea. We can run it by and say, does this suck? And they say, well, so far so good. And then it can get to the point they'll actually give you good pointers and say, you realize this is good. They may not agree with your final conclusion, but they said, well, your methods are impeccable. Your citations are good. Um, a lot of your deductions are good. It just doesn't agree with evolutionary theory, but you know, uh,
Mhm.
um, and I think that's one way to avoid these problems and then accusations of dishonesty, because at least you get to hear the other side. And when you note it in your book and say, okay, obviously we disagree, but I'm going to let the other side have their say.
I think
And
that's a good point.
the mechanism of how this is going to be interesting, because the way I might do it is I'll have my websites and say, okay, here are my publications, and if you want to hear the contrary view, one that I think is honest, I mean, I will not tolerate dishonest. What I mean by dishonest, Dave Farina, uh, like any biomolecule is easy to make because we have machines that can make. I'm just like, no, dude. Even your secular colleagues would call you out on that, something so ridiculous.
Yeah.
Um, so, and to be able to get the what I'd call the hostile review means trying to develop a relationship where you show enough respect that they'll reciprocate and say, that I disagree with that, but you know I think it's valuable to say, okay, I agree with this part, I agree with this part, I agree with this part. That's still better than saying everything from start to finish is awful.
Yeah,
I
I
got
think this.
Yeah,
Sorry, go ahead.
because I got the impression Erica was like, contested bone start to finish is awful, and dismantled start to finish is awful. It's like, okay, um, I'd like to have my stuff reviewed, and it was nice when Dr. Dan came on my channel. He said, "Okay, I agree with you on that," and I'm like, "Okay, I agree with the math. I think it's like okay, and at least not your whole work is considered utter garbage, I mean, it's meaningful that you can at least get some common ground. He might say it's irrelevant or whatever. It's still, I
Hmm.
felt it was, and I think as we have that dialogue, it's going to be better for all of us. And one thing that's helping is more and more of us young Earth creationists are starting to matriculate through university. And if you're any good, I mean, it depends on the school you're at, honestly. Um, Sometimes you'll have people that are evolutionists that will really stand behind you because you're talented enough. Now, I can't I can't say how you're ever going to find that out because sometimes you run into stinkers, and there are all sorts of political things. Even if you were an evolutionist, that would be barriers. So I can't help there. Um,
Yeah, I think this kind of somewhat goes back to the issue of kind of the hypersensitivity that has kind of been created. I don't know. Maybe just um yeah, I a lot of people just do not want to ever admit that they're ever wrong about anything. That is just so fundamental to science in general, and it's so necessary. I mean, uh when people face criticism, I think it's our natural tendency to kind of draw back and just defend everything we ever said. But I think, um, as you kind of pointed out, that the whole purpose of science is to peer review, right? And to get other people's opinions. And when you, yeah, whatever.
well, I think the problem is, and it's difficult because people are in such evangelistic modes. And
Right.
as Christians, we are to be evangelists, but it's like, okay, you don't sacrifice honesty and integrity. You don't represent something as fact that is something you made up, or you haven't. Maybe it's less of a sin to put something forward that you just didn't research that well, or you didn't vet it well by consulting the opponents. But it's still the problem of trying to be an evangelist at all costs. And you want to be an evangelist that tells the truth, and the truth is that you believe this. You have some evidence that makes you believe it, and there's some problems you haven't resolved. That's the fair thing to say. So just like what you said, and you and I were saying, okay, we have problems with the stratigraphy. And what
Mhm.
I said is, I think that's a lot easier problem than solving abiogenesis or eukaryotic evolution or many of the major transitions at the molecular level. I'd take solving stratigraphy over that, you know. And
Mhm.
I think that's an honest answer.
And I think, let's see, what was I just going to say? I just lost my train of thought. By the way, for Dan, I will put in a good word for you. So just so you know that.
And you see, I think long term it's going to help the creationist case. It's like, okay, just stop trying to say things that you get accused of dishonesty, because you just talk to the other side and have them go on record and say, no, I don't think that was dishonest. I don't agree with your characterization, but I don't think that was inherently dishonest. I think you're wrong. Dishonest means that you knew it was wrong and you said it anyway. Okay, so there's ways to kind of to do this, and because it, there's a I think there are mechanisms to do this where you're not going to just be called out, because if you could say, okay, do you agree that there's uncertainty on this question and that we'll have opinions? You can get a lot of agreement there. You could say, okay, there are going to be differing opinions and there's uncertainty. This experiment has to move forward to help us resolve this. We can we agree on what experiment or observation would resolve our disagreement?
I remembered what I was going to say. I was going to say, yeah, that's some of the problem there is kind of the breakdown between the people who are actually doing the research and then like popular people who are trying to kind of popularly spread things, right? And I think in the actual fields themselves, there's a lot of nuance. There's a lot of a bit of a different perspective than the people who are just trying to popularly kind of convey things. And often that creates a big issue, right? For especially in the field of young earth creationism, I think, because so many of the people are ones who would more like to just be popular level speakers than who are actually doing research.
Right. And the popular level speakers like Kent Hovind are just like, it's like, I wish you weren't on my team. Sometimes I think you're just an evolutionary plant because some of your stuff is so bad. All right. So now I will talk about an ID and creationist argument that I think is just horrible.
All right.
Second law of thermodynamics is proof
yes.
evolution doesn't happen. I'm just like, please, before you use that argument, see if you can do.
Try to define entropy.
Well, you don't even need to define it. Do a calculation on what's the change in entropy going from the dead state, let's say a living mouse to a frozen dead mouse. Can you do that calculation? I'll give you another one. All right, if you're if you're an engineering student, a student of physics, or a student in chemistry, you ought to have some ability to determine what has more entropy, a warm living human or a frozen dead rat. A warm living human has way more entropy than a frozen dead rat, for the simple reason the more water you have at a slightly, even at an equal temperature, the more water you have compared in one system compared to another, you have more entropy. Human has way more water than a frozen dead rat, not to mention it's at a warmer state, therefore has more entropy.
Do you have an idea where that even like originated, that idea about entropy, like being a challenge to evolution?
How it came? I've speculated it was Duane Gish. And also because the original Boltzmann and Gibbs used, Boltzmann specifically said disorder and Gibbs said mix-upness. And because they're founders of thermodynamics, the pioneers of entropy concepts, those passing remarks that are qualitative descriptions just persisted. The more that we began to elaborate and study entropy, it began to be apparent that that's not a very good description.
Yeah.
We can actually find systems that are at higher entropy that are more ordered than other systems that are, okay, you could have higher entropy systems that are more disordered than lower entropy systems that are actually more disordered. I'm messing that up.
And the whole fact that the Earth isn't a closed system, I mean,
yeah.
it
So
just causes so many problems.
So this whole thing that when they said entropy is a measure of order and disorder, in old chemistry books, you'll see it, maybe some physics books, but that's changing. I forgot what his name was. He ran the entropy site He died at age 100. Frank Lambert, and he said it had nothing to do with creation evolution as much as he said this is just killing the students, because when they actually study entropy, and there are two definitions of it, the Clausius definition, which is the integral of dq over t, and the Boltzmann one, which is S equals KB natural log of omega, and omega is just a bear to figure out. I mean, I studied statistical mechanics and thermodynamics in grad school. That's a monster. What a microstate is not trivial. Um, and as I studied, I'm like, where's the term for order or disorder? And then who was it? Robert Gange, who's a creationist, actually said, okay, you could take two systems, one has higher entropy than the other, but the one at higher entropy is actually more ordered. He was specifically looking at the gas molecules, and then there's probably some crystal examples. But like I said, the easiest one is you take a warm living human versus a frozen dead rat. I'm like, well, you'd think because we're talking about lowering entropy that the warm living human must have less entropy. It doesn't. It does have better in functional organization, but entropy doesn't measure that. Thermodynamic entropy does not measure that. People say, well, you just need a larger definition like Jane's. I'm just like, you know what? This is getting so far from what thermodynamic entropy is. It's starting to become meaningless. Why don't
It
you
just
just come
doesn't
to the
apply in the slightest.
Yeah, yeah, yeah. So I'm just like, you have such better arguments, or you're going to start off with one that you're going to get your head handed to you. This is terrible. And people, other creationists who don't know, they'll say you're dead wrong. And I said, how much thermodynamics and statistical mechanics have you studied? Have you studied it at the graduate level like I have? Sometimes that doesn't stop them. They'll just keep insisting. It's like, okay. So do you have another one? Otherwise, I have another one.
We've just been informed by the chat, by the way, that the ghost of Henry Morris walked behind you.
Oh boy, I'm in trouble.
Yeah, I have another one here. And that is that Australopithecines are, well, when conventional scientists reconstruct the Australopithecines, they give them human hands and human feet to try to convince the public that they were evolving into us. And the issue is that we have hand fossils and foot fossils from both of the major species of Australopithecines. So we know what the foot looks like. And for some reason, this has kind of become a major talking point of everybody, that we somehow don't know what their feet were like, and thus evolutionists are just making stuff up basically as propaganda to help their point.
Okay.
And it's simply not
Thank
true.
you.
And I hear a lot of people, for example, repeating the line, no hand or foot bones were found from Lucy. And literally, like in the book, next to that statement, you will see a picture of Lucy with hand bones and foot bones. And yeah, I just don't know what's going on. I mean, like it must be just such a talking point that's been repeated that these people are just taking it at face value and not even examining it in the slightest.
Yeah, this is a hard lesson to learn. That's why it's important to have a dialogue with the other side and say, is this correct? And in the absence of a dialogue, listen to your opponents and try to carefully consider that they might be right.
Mm-hmm. And kind of connected to this is kind of sometimes a lot of people will focus on a few specific figures in the past. In terms of hominins, everybody likes to focus on a couple people. Let's see, who am I thinking of? I cannot think of the name right now, but there were some kind of conventional scientists in like the 1930s that stood out from the rest, and their ideas are just continually recycled, even though they were disproved. But connected to this, yeah, a lot of the time we had this very fragmentary evidence to kind of begin with. And so maybe some of the early fossils that we found, we didn't know very much about the foot or the hand, but often over the years that was clarified quite a bit by further discoveries, and people aren't taking the time to look into that, even though they are broadcasting stuff to the public about the subject. Like, for example, the foot of Littlefoot. Littlefoot is this very famous Australopithecus skeleton. It's the most complete one ever found. And originally they found only a couple bones of the foot. And in chimpanzees, basically the big toe sticks out to the side, kind of like how your thumb sticks out to the side on your hand. And basically there was this whole debate about whether or not it stuck out or not in this Australopithecus, right? Because that kind of tells us whether it was walking more similar to a human or more similar to kind of earlier hominins. And there were these early reconstructions where they only had one bone of the metatarsal. So they didn't even have like the second metatarsal. And so basically they were comparing, they were trying to figure out how much the big toe stuck out without having the second toe. And that's very hard to do, right? And so it turns out when they found the second toe that it didn't have a divergent big toe, indicating the foot was human-like and could have made footprints like the Laetoli footprints, for example. And so kind of, yeah, that idea that evolutionists just make up stuff about these Australopithecines to try to convince us of evolution, when in fact that is a very factually based thing.
Thank you. I may have missed some of the nuances in that, but everything you've said is all the more reason I'm glad I never waded into this whole field, because one of the things is, okay, let's say it was made up. It doesn't change the fact that when I do gene browsing, that I see that we're very similar to chimpanzees and gorillas.
Mm-hmm.
We even assuming we had charlatans in one field, you can't deny that you had the mosaics, or like you said, that's a better word than transitionals, across species. You have this progression. It's undeniable.
Yeah, there is some pattern to life. The question is what that pattern represents.
Right. And I've said that it is a pattern that is optimized for scientific discovery, particularly for humans with 21st century technology. For like that pattern I said where we could do AlphaFold predictions because of the species type, we couldn't. It's only in this century that we can do it. It's like God had foresight to where we would be to discover this pattern. It would have been a mystery if civilization didn't reach this point. And it's like this is a pattern that God seemed to anticipate that we would discover eventually. So that is my explanation. And that's why, yeah.
Part of that, right? He even pointed out to people, I mean, the whole distinction between clean and unclean animals, and also, of course, him giving Adam the ability to name the various kinds. All of that was kind of connected to that.
Wow. All right. Now my next one, and I'm going to get flack for this. Let's see, which ones did I cover? Irreducible complexity, no transitionals, bad argument.
Entropy.
Next one is DNA is a code. It may be a true. Okay, let's grant that it's a true statement. It can be deflected, and you get definitional arguments again. So let's grant that John Maddox is correct when he's citing all these people like Perry Marshall and Richard Dawkins that it's a code. The evolutionists have done a very good job. We're trying to defend abiogenesis and say that's just a metaphor. It's not really a code. And it'll go back and forth, and they'll say, how do you prove that it's a code? It's just going to go in circles. What the real thing you want to do is to show that the genetic system, that the genetic code, whether it's just a metaphor or real code, it's improbable. That's what it's getting too sidetracked in going into these vague statistics of like, well, there's no language that isn't designed, there's no code that isn't designed, therefore DNA is designed. It's like, well, it's kind of the right intuitive argument, but it's not rigorous.
So I think your point is that there are much more basic fundamental things that are much more easy to prove that can completely undermine these arguments at the top.
Okay, Icarus says the genetic code is a code. And I would agree, but I'm not going to use it as an argument for intelligent design because I know how the other side's going to react. What I would argue is look at the last Discovery Institute, long story short, on transmembrane proteins. And I'm sorry to pick on Erica, but it's just because I followed some of her debates. And she was debating John Maddox, Mr. Code argument himself. And he was throwing the code argument, and I was moderator of that debate, and I was just cringing every time he brought that up. I was thinking, John, why don't you just argue the biology and chemistry? You don't need to go to this detour. Take the direct attack. And he kept doing that. And then Erica came back, and she alluded to the experiments, I think, where they're able to create lipid bilayers. Mm-hmm. And those are the experiments that claimed, hey, and Dave Farina quoted it and said, hey, it's easy to make a lipid bilayer. It's so easy to make a cell. Well, this long story short by the Discovery Institute just blew that away. I don't know if you saw it.
I did not.
Okay, this was
I'll have to check
11 minute obliteration. And I've studied transmembrane proteins and talked about just like, yeah, you're going to win this argument every time if you do it right. They are very good on every level of pointing out why that was just ridiculous, because a cell membrane, if it doesn't have transmembrane proteins, it's going to be a stinky tomb where the things inside just rot to death and die from starvation and the inability to expel waste. And what you want to do is have membrane proteins that can control the flow of materials in and out. And they showed the complexity of these, where something the size, like say, of a fly, which is a proton, versus the size of, say, a country, like a big European country. These transmembrane proteins can prevent protons from coming in, but then let something the size of a country come in. So it's like I can let a fly in, but then block something the size of a country, because they're showing the relative sizes of proton versus a big macromolecule. And my jaw dropped. I'm like, that's pretty clever how you can build these transmembrane. And then I've shown what they call the translocation process, where you actually have to stitch the transmembrane protein into the lipid bilayer. It's like stitching a buttonhole, but it's like, this is not trivial. It's even more complex than that. I said, don't use the code argument. So that's my, John Maddox is my friend, but he knows I don't like that argument. I like the transmembrane. And there is a book written by Change Laura Tan, The Stairway to Life, that is a different take on the way James Tour argued it. Those are very good complementary approaches. And, because it was James Tour who worked for a Nobel Prize winner, that Nobel Prize winner rejected abiogenesis. His name is Richard Smalley. So, and then Change Tan and Rob Stadler, she was chosen by a Nobel Prize winner, George Smith, to be a molecular biologist. So I'm just citing the fact you've got it handed to you, written by experts, and the easiest way to see it is just go to that 11-minute video. You could see the quality. So that's up to me that's so far what I have for four of them. So if you've not run out, feel free to give one, a couple more.
Okay.
And we could shut down.
I've got one here, and this is folded rock layers. And this is something that I don't think is necessarily a terrible argument, but also in the form that it's presented, it's often presented as some sort of slam dunk, which, from my understanding of geology, it is not.
Okay.
So the idea of folded rock layers is that you've got these units, right, that are these strata that sometimes you find and they're buckled and you have these extremely crazy curves. For example, I actually have some in my collection myself, some little tiny versions of them where you have the completely folded turned rock layers. See you, Dr. Duff. Thanks for joining us this evening. Anyway, the creationist argument goes something like this. If these rock layers had hardened by the time that they this kind of tectonic movement happened and it started to deform the rock would have simply broken kind of, and it wouldn't have been as smooth of a fold as it is. And they would then say, you know, that we should only expect very limited fracturing. So basically, you know, the rock splitting in pieces as it tries to bend. And the problem is that there have been very, very extensive looks into this. I mean, where you can actually model the math and the effects and the stress of the rock. And basically, there's a number of different factors that can play into how much you can get a rock to bend. And sometimes, here's a few of them. One is heat. Obviously, you know, if something melts, it becomes more flexible. Also, given enough time, you can try to deform something so slowly that it doesn't actually break. There's also just kind of pressure holding things together, not allowing it to fracture. And then also you can have liquids actually come in there and help modify kind of the rock to help it change shape. So now creationists, often young earth creationists, like to argue that there isn't enough fracturing, but the problem is often there is often very big fractures in these bent rock layers. And even when there aren't like huge fractures, there are often microscopic fractures where you can see that the rock has broken. So overall, while I don't think this is like the worst young earth creationist argument, I think that the way that it's often presented as being so definitive isn't correct, and that there's a need for actual modeling and actually like testing out all these different things before people should present it that the way that they often are.
Now, do you? I will say this. I think the idea of these very discrete contact layers and discrete, sediments. I do think that argues more in favor of rapid
I think so.
sedimentation. Yeah.
I
Okay.
agree.
So we're on the same page there. So
Yeah.
with the folded rock, at least the stratification mechanism looks reasonable, because that has totally bothered me. It's like, how does it switch from one kind of sediment to another so nice and discreetly? That is, especially across large areas. I'm just like, okay, was it eroding one mountain that happened to have that one class of sediment, and then it stopped, and it's the other mountain that gets eroded? I'm just like, okay, I don't know, but this doesn't look good.
Yeah.
And
No,
also the fact
just
we have
specifically the folds.
yeah, it's the folds, but not the contact layers. So
Yeah.
okay, so what's my next one? Accelerated nuclear decay, and I've talked about that enough. I've just basically, I said I think the evolutionists are correct. We need lower energy methods, and the reason I say that it's a bad argument is there have been a minority of young Earth creationists that said it's problematic that our blood doesn't boil or we don't die from potassium. I think it's 40. If there's accelerated nuclear decay, we should die. I'm just like, okay, I think that's a deal breaker.
Yeah.
Not to mention, if you're monkeying with the strong and electroweak forces, you could blow up the universe. So
at that point, it's basically just on the level of like the canopy model, right? I mean, like you could try to postulate it, but you need just continual miraculous upholding. And I just don't like fitting in miracles where the Bible doesn't say a miracle took place.
Yeah. No, I understand. I understand the sentiments. So, long story short is here. Oh my goodness. Yes. I said, why does that sound familiar? Yes, sir. If I had 1 hour to present intelligent design, it would be that third episode on transmembrane proteins. We are honored, sir, to have the author of Long Story Short here on our channel. And that's the best. I said, and I think Paul Nelson wouldn't mind me saying this. He thought that was the best one of the three so far. And if I had 1 hour to present my case to the world why I believe in intelligent design, I'd spend 11 minutes showing that video. Absolutely. Absolutely. And so we're graced to have you here. So I'm going to leave that comment up. Oh my goodness. So that's my feeling on accelerated nuclear decay. Not only does it have a heat problem, a more basic level, it's how do you avoid it killing humans and any life that has a significant amount of potassium, a sufficient amount of potassium to kill them, and plus the nuclear decay. The heat problem. So I have said, look then at not accelerating nuclear decay. If you just change the nucleus, you've done just as good as, maybe even better than doing nuclear decay. You just changed the nucleus. You've circumvented. And better yet, you might be able to make the right spectrum of isotopes in the right proportions. And that's why I've explored both photonuclear processes, mixed energy reactions, this thing that's called where you have high density electrons creating quantum attractions that will lower the Coulomb barrier, and then now the heavy electron quasi-particle model. And that is a mouthful of theories, but I'm just like, we're not limited to accelerated nuclear decay. We have mechanisms that actually are very well verified, or at least theoretically promising. And heavy electron quasi-particles, I put in the promising. We have some experimental evidence that supports it. Practically everything I said has good experimental evidence, some of it better than others. Whereas accelerated nuclear decay, what we call isotropic, meaning universe-wide, there's no evidence of that. And there's no evidence that it would succeed without killing us, incinerating the earth, etc. So I put that, on a list of bad arguments.
Yeah.
I'll turn it
I
over to
mean,
you, Peter.
what's kind of your position on using miracles? Because in my view, I'm not going to ever propose a miracle to do anything where the Bible didn't specifically state a miracle happened.
I think I lean toward your position. I'm not opposed to invoking a miracle here and there, but I think, and this is just, maybe just kind of a theological viewpoint that I can't justify. It's more intuitive. That God structured the universe so that we could reconstruct history with, starting with naturalistic assumptions, and where it leads to an irreconcilable contradiction, that's when we can invoke a miracle. So actually, no, going back to what your question is, I would say just even without the Bible, just start with naturalistic assumptions. It will lead to contradictions. It'll tell you where the miracles are. And one of them is obviously the origin of life. Well, the first one's the origin of the universe, the fine-tuning, origin of life. The secular world has grudgingly conceded these are miracles. They won't use those words. Francis Crick, Nobel Prize for discovery of DNA structure, he said it's
Yeah.
almost a miracle. I'm just like, well, yeah, you had the right sentiment. So that would be my policy, because I think God would want it to be really clear how things transpired. And so if we have to invoke a miracle to justify the big parts of Noah's flood, I'm just like, well, then it's not a compelling case. And Romans says it's going to be so strong that it's without excuse. So when you can just throw a miracle to fix everything, then it stops being a compelling case. So for that reason, I try to avoid that. The one area I would invoke a miracle for Noah is that maybe the feeding and care of the animals, and obviously why the animals would even come on the ark to begin with. I would think there had to be some divine incentive for them to actually gather to Noah, that he didn't have to go out there and grab them all. So I mean, but then again, as you said, that's in the Bible. It's suggesting that that
Right.
was a miracle.
And the same thing with the origin of life in the universe. So yeah.
Yeah. So this accelerated decay, eh, you know, um,
For the person in chat, I'm not saying I don't believe in miracles. I'm saying I don't want to make up miracles where the Bible doesn't say there weren't miracles. That's the whole point. I'm just saying
that's a good
I
point.
don't want to bring up some sort of miracle and say, oh, God just radically happened to transform this thing to explain my theory, because my theory is based on my assumptions, whereas the word of God is based on what God has said. And thus I'm going to trust what he says about what happened.
Yeah. So I believe in miracles. I could believe in them even without the Bible, because I'm seeing evidence of them. But the reason I believe the Bible is because the miracles described by my experience and understanding accord with the Bible. And Jesus said in John 10:38, if you don't believe me, believe the works. And I think the universe and the historical record are constructed to testify of him. So I'm almost out of kind of all the off the cuff bad arguments for ID and creation. There used to be a lot of stuff with information theory that was trying to be used in ID. And I actually studied graduate level electrical engineering communication theory. I still have my textbooks, principles of communication.
Oh, yeah.
And I had to learn Shannon's theories, and I had a digital communication book here. So, and so when I hear these guys opining about information theory, it's like, how much information theory have you actually studied? One thing one will realize when you start studying all the theorems of information theory, it's like, what relevance does this have to do with ID? Because this is like, you're talking about information theory as far as being able to have a sender and receiver, where the sender and receiver agreed on in advance how to construct what the communication policies and codes are to begin with. You don't have that with necessarily life. So you have information like constructs, where you could say the genome has like 6.6 gigabits of Shannon information, and that's about it. To be able to say that it is organized in a way that can express functional systems, you don't need information theory for that. It just adds confusion factors. So that's kind of like, and then they say, well, then there's no information increase in evolution. I'm just like, oh, you're going to get into those definitional arguments that I just absolutely hate.
What is information?
Yeah, exactly. Now, what I do use is the idea of a recipe or a construction blueprint. If you use kind of the qualitative, it's like, okay, the organization of the nucleotides, meaning the sequence, it has to have a certain sequence to make proteins that have functional structures. And what I mean by functional structures, I can identify some of the functional structures. Like a transmembrane protein has certain properties that are improbable, just as a matter of principle, to get it to it. It does. It needs to have certain code segments that are like passwords, because these are like postal codes for proteins to be located. I mean, something really basic. For proteins to be located in the right position in the cell, they actually have codes on them. They're sequences. And it's like, yeah, you can't have random organization and get those codes to be just like when you write a letter, you have to put the address in the kind of the right
Yeah.
spot. You know, you can't spread the letters all over the place, and it has to be organized the right way. The proteins that are located particularly in eukaryotic cells have postal codes, sometimes multiple ones in their DNA and in their protein or RNAs. And this is not easy to do. So I don't use the word information. Information increase never happens. You'll get yourself in trouble with that. I will say that sometimes, um, un, you know, for lack of a better word, mutation and selection can generate a little bit of novel function, but the net direction is loss of complexity. And what I mean by complexity is uh, the number of ways you could break something. So, like just very simply, if you have a working password and it's a small one, you can break, just up to the number of letters of the password. If you have a very long one, you have a lot more ways to break it when you try to enter it and you miss a letter. So that's kind of a nice qualitative way that I define um,
Okay.
complexity.
Yeah. One maybe kind of final thought. What do you think kind of about the idea of beneficial mutations?
Okay.
Because because like from my perspective, I mean, trying to argue there are no beneficial mutations is somewhat semantical, because you have to somehow define a standard by whether something is beneficial or not. And I think we could agree that there are certain things which are detrimental because they might lead to death. But I think it's harder to come up with an objective standard of what exactly makes something beneficial or not.
This is a great point. And there's the evolutionary definition, which is a total mess and absolutely useless. And I'll give a proof from an evolutionary paper. Richard Lenski he co-authored a paper. He was not the lead author nor the last author. Last author is usually the guy in charge of the team. And I don't have it off the top of my head, but he said genome decays despite large fitness gains. And I laughed. A fitness gain means you got beneficial mutations that were selected for and increased in gene allele frequency over time, which is microevolution. And I was laughing. I said, your genome is going down the tubes, but your fitness is going up. Something's really screwed up there, guys, about your definitions. So you're arguing we got all these beneficial mutations and they're increasing in the representation in the population, and the genome's getting trashed. And I'm like, well, the problem is your beneficial mutations are actually loss of function. So you're selecting for organisms that have lost genes. This is a disaster. So that's my view of the evolutionary. Oh yeah, Reasons to Doubt asked, did I cover it? Yeah, I said the heat problem's the worst. I said second law of thermodynamics is a terrible argument. And
Australopithecus may have drowned. It's actually found in a cave system, so it's actually it's pretty obvious that it actually fell down into this cave
yeah,
system and got covered.
why don't I try to summarize what I was, and then I'll get back to the. Well, let me finish with PaleoLogos here. Um, his question on beneficial mutations. So, Dr. Sanford and I are writing. He actually called me up last week, and I'm late responding. I mean, I'm late getting to my assignment. He asked me. He said, "Hey Sal, can you can you give a shortened, collection of quotes that, from our last paper, and then the ones that were on the cutting room floor that didn't make our last paper, really our chapter in Springer Nature, and talk about, the problem with fitness? I said, sure. And I haven't gotten around to it. But that one quote by Lemsky says it all, that the genome's decaying despite large fitness gains. I just laughed. I said, you see, the two are uncorrelated, and that's the worst thing you could ever want. And they generally are. And Behe made the point, most beneficial mutations are loss of function. That's just devastating. So then the question is, well, then how do you, okay, so that's the evolutionary definition. So we haven't really come up with a good alternative conception except to say suitability. So, for example, a submarine is suitable to operate under the sea. It's not suitable to operate in a desert. And you can describe this in terms of just the mechanics of it. You don't have to relate it at all to reproduction. See, evolutionary biologists define fitness in terms of reproductive success, and that's why you get absurd statements like the genome's decaying despite fitness gains. They're already starting to see the seeds of the problems here, that its definition of beneficial is decoupled from the idea of engineering functionality. And so this is a promising result. So yeah, if you want to get evolutionary beneficial mutations in the evolutionary sense, it's really easy. It's called reductive evolution, where loss of genes is a beneficial mutation. It's very easy to get a beneficial mutation in the evolutionary sense. Is it hard to get functional improvements? Yes, very hard, particularly going from one major protein form to another. And this is, again, my CRS talk, because I'll show some examples. It's like, it's going to be so obvious, it's ridiculous. Just to give an idea, it's just like if you have a car part, and it fits, like say a screw into a hole. You can't change the screw without changing the hole. Or like, how about the lock and the key? And there are lots of things in biology. If you change one part, you're just going to break it. There are more ways to break it. You're certainly not going to improve it. So if I start to take a file and just start to, or pound on a key, I'm not going to improve its fit into the lock. Every way that I mutate it, quote unquote, is going to be detrimental. You definitely see this in transmembrane proteins that are ion channels. Every change is detrimental at best. I mean, at best, it's neutral. You hope it doesn't have a negative effect. At worst, it's detrimental, because the tolerance, just like a screw inside or a lock inside a key inside a lock, the fit has to be just right. It has some tolerance, but not much. But in a sense, you're not going to improve the performance of the key by mutating it. Every direction you mutate it, at best, it's neutral. At worst, it's going to damage it. And you actually see those geometric things. So I've tried to teach creationists, look at just the geometric connectivity. You'll have a better argument for describing why most mutations are detrimental. Trying to go into this definition of detrimental based on reproductive success is just the wrong way. I hope that helped.
Yeah. Yes, reasons to doubt entropy, and entropy did get brought up, and the heat problem connected.
See if I could summarize what I said are bad arguments. Oh, I'm sorry, Peter, I interrupted you.
Oh, I was saying, and the heat problem in its connection to
young Earth creationism.
Yeah, and accelerated radiometric decay.
So I said, what were my arguments, if I can remember them? Irreducible complexity is the right sentiment, but the implementation is bad. Don't use irreducible complexity. The next one is, don't say that there are no transitionals. That's just going down the wrong path. The next was, don't use the second law of thermodynamics as an argument against evolution and abiogenesis. There's still, even my colleague Brian Miller uses it, and I'm just saying, no, that's wrong, very easy to calculate that a warm living human has way more thermodynamic entropy than a frozen dead rat. Just calculate use the entropy standard molar entropy tables, and anything with more moles of water has more entropy than a creature with less moles of water, just roughly speaking. I said DNA is a code is not a good argument, even though I believe DNA is a code. It doesn't mean it's a good argument. Use long story short's transmembrane show, which is only 11 minutes long. That's the killer argument against abiogenesis. And I said information increase is not a good argument. Oh, and then I said increased accelerated nuclear decay is a bad argument because even young Earth creationists have said it is.
To recap mine, my first one was that the argument that modern humans predate the Australopithecines, or that's just a bad argument. It's based mostly on very, very fragmentary evidence and fossil footprints that can't be readily assigned to a singular species. I also mentioned the argument that they never found hand or foot bones from the Australopithecines, and evolutionists are making things up about that, which isn't true. I also brought up the distinction between micro and macro evolution has to do with species and not kinds, and it's just a semantic argument that people shouldn't really be using. And then I also mentioned Jeffrey Tompkins and the kind of human chimpanzee DNA situation and why that is not a good argument that you should use in support of young Earth creationism either. And then finally, that folded rock layers aren't really kind of the slam dunk that many people would treat them as if they were.
Well, thank you. I think I learned a lot tonight, and I hope you got
I did too. It was great to hear kind of your input about some of that, and especially about the genetics and everything.
Yeah. So, you've given me hope for the next generation of young Earth creation researchers. Do you have any aspirations to continue in this?
I do. My goal is to kind of become a paleoanthropologist, so studying the fossil hominin record. And kind of specifically because we don't have any young Earth creationists who have ever done that before. So I think it's kind of a place where we need to expand.
Well, best of luck to you. I don't know how many schools would be willing to accept you, but if you can get through there, I'm sorry we didn't get to all the side chat questions. When we focus on a show, sometimes we just focus on the material we're talking about. So apologies. And to all the Christians out there, I'd like to wish them a very happy Easter as we celebrate the resurrection of our Lord and Savior. So, Peter, I'll meet you backstage, and we're signing off. Take care, and God bless you all.
Yes, have a good evening.